So in this second part, we will continue with the second meridional effect back here, which is a meridional effect with two channel connections. That means we will need a different type of CR effect. First of all, with two connections, and we will need a rotor-stator interface here. And we will try to match both this CR effect right here and also this one. We will try to connect it with a matching connection to the channel. So that's basically the topic of this extended part, and let's get started. Let me just remove this. Okay. So the first thing I will do here is I will select this turbo assembly and click this button right here which says add CR effect with two channel connections. And if I do that, I get a second assembly right here. I will just rename this and I'm going to call it Shroud Leakage Path Impeller 2. And as we did in the first part, we will have to define the boundaries. However, in this case, Fidelity will require us to provide two curves, which is not a big problem. So I will go to boundary definitions right here. Keep in mind that these two symbols are red at the moment. As soon as I define the curves correctly, I will have two green icons here. The second part is we will have to define a curve for the rotor-stator interface. If you have this curve already here, you can just select it, or in my case, I will click Create Edit Rotor-Stator, and I will draw a line approximately in the middle between these two ends. And that's all we have to do here. I will close this up again and we will continue to the mesh setup. So as you can see, now we have two new domains here. One domain for the left-hand side, or the upstream part of the rotor-stator phase, and the part downstream of the rotor-stator interface. So if you remember, we want a matching connection this time. In order to get a matching connection, the first thing for a radial centrifugal compressor with a blunt trailing edge, what we'll have to do is we will have to change a little bit the topology of our row, because what we are going to need is we will need a fixed Z constant line at the trailing edge of the impeller. So you can imagine if you have the grid coming up here and you want a matching connection to the channel, we will need a Z constant line here and here in order to distribute the cells in a way the ZR effect can connect to the main channel. And in order to do that, I will enter the blade-to-blade settings, which I can do here in the blade-to-blade view. I will scroll down, and the first thing I will have to do is I will switch the outlet type to normal. So what you see here are settings for the high staggered blade optimization. I will not go into details on this. If you need details, give us feedback and we can do a life hack on that as well. Bottom line, or the short version is, if you have a high staggered blade, you will need a slightly different grid topology in order to get a good grid. So here we are compromising a little bit in the sense that we say we accept a slightly worse or not as good as a grid in the main channel, but therefore we get a matching connection with our meridional effect. So I'm switching here to normal, and then as soon as you do that, you get this additional option here for Z constant line at trailing edge. And I will select that. As soon as you do that, be sure that you reinitialize your grid topology. So if you just change the number of points, you can always just recreate the blade-to-blade view. But as soon as you change your topology, which is what we are doing here, you have to reinitialize your grid. And I will do that here by clicking on Initialize Blade-to-Blade Topology and Grid Points. Then we get an updated version of our grid, and as you can see, now we have this fixed Z constant line right here, which means the grid, or this grid line right here, will be at a constant radius along the azimuthal direction. So that's the first step. The second step will be that I will remove this line right here, and instead I will let Fidelity automatically create matching Z constant lines based on the grid point distribution in my ZR effect. So let me just demonstrate this. I select my meridional effect after the blocking and everything is finished, and I will click on Add Matching Z Constant Lines. And now I get 3 new lines. Now there's one last thing that we have to consider. As you remember, we already created a Z constant line on the trailing edge in the blade-to-blade topology. So this line right here would be redundant, which is why I will delete it. And I will select those 2 lines right here and set them to linear. Be sure not to use R constant, because R constant will most likely shift your Z constant line in a direction away from the ZR effect. So I will just select linear, and I would say this looks quite well. I will just update the flow path and the blade-to-blade view. Let's view this in the blade-to-blade view, and as you can see, now we have a grid point distribution adjusted to those cells coming out of the ZR effect. So this is actually something. Now we can connect both grids with a matching connection. So I will not be able to create the grid yet because, oh, actually maybe I can. Let me just select the first impeller, and so 1 second, I will select the first impeller and the first ZR effect, and I will create the grid. Let's see if that works. Okay, let me just check in the 3D view. Great. So as you can see, now there is no more patch in here, and that is a sign that now we have a matching connection and there will be no interpolation taking place when exchanging the variables here at this location. Okay, that's a strategy if you want a matching connection. The last thing we will now do is we will take a look at this ZR effect with 2 connections to the flow path. The first thing we will do is I will select one of those domains. I will also increase the number of the optimization steps here, and I mean similarly as we did for this domain right here, all I do is I select automatic blocking in order to get blocking and a first preview of my grid. I will probably deselect those two options. If you want to know more about this, feel free to shoot us an email or just take a look in the user guide. I will try to keep it simple here. I will redo the automatic blocking. I will take a look at the default mesh and run the optimizer. Here we have the line for the rotor-stator interface. And I would say that looks good so far. So as you can see, there's really not much we have to do. The work comes a little when you want a matching connection, which I will demonstrate again. I will switch to the blade-to-blade view. And as I mentioned, we will need a Z constant line at the trailing edge. So I switch to normal at the outlet and I activate the Z constant line at the trailing edge. You have seen this before. I will reinitialize the grid topology. There. And I will delete the Z constant line here and replace it with matching Z constant lines from the ZR effect. And if I click this button right here, as you can see, now I get 6 new curves. 3 at the inlet and 3 at the outlet. Remember, this one right here is redundant. We will not be needing this. So I will just delete this and click the remaining ones and setting them to linear. I will update my blade-to-blade view. And as you can see, this seems to have worked, both at the leading edge and at the trailing edge. Of course, now we could do some mesh modification here. I will just keep this as is to show you the final result. So let me just redo the mesh generation right here. Okay, we are finished. Let me just take a look to make sure everything is in order. So as you can see, so maybe for your orientation, we are now looking at this location right here, where our seal is for the shrouded impeller, and here at the exit of this stage. And as you can see, we have our seal right here. We have a matching connection both at the inlet and also here at the exit. And in between we have our rotor-stator interface. So let me just take a look at the global grid quality. So yeah, it seems we have a few bad angles in the shroud leakage path of 8 degrees. That is something, of course, that could be better. We could do some additional grid refinement and work it a little, but I think the general idea should be clear. So that's pretty much all I wanted to show for today. I hope this will help you in the future in your workflow. If you have questions or if anything is unclear, please be sure to shoot us an email, and yeah, have a nice day, and bye-bye.